Okay, today we're going to be learning about how to solve and graph 1 and 2-step inequalities. So first, let's go over some of our rules, which you should remember from graphing inequalities in past years. First, you are going to use an open circle. Fill this in with me. An open circle for less than and greater than. And you use a closed circle for less than or equal to and greater than or equal to. So one thing that I do to help me remember this is that if I have to take the extra time to draw that line underneath the symbol, then I have to take the extra time to color in the circle on my graph. All right, continuing down on our notes, let's talk about how to graph them. So just kind of some examples of what we've just seen. So our first example has x is less than 3. And I'm going to go ahead and write that out. X is less than 3. So that means that I have to put my circle on 3. And then because it doesn't have that little line at the bottom, because it doesn't say or equal to, I don't need to color it in. I'm going to use an open circle. And then I'm going to look for all the numbers that are less than 3. Well, what I like to do to decide my arrows, I look at the number to the left of the circle and to the right of the circle. So here I have 2 and I have 4. And I need to pick the one that's less than 3, that's smaller than 3. So my arrow is going to go to the left here. Let's look at that next one. So now this one is x is greater than -1. So I'm going to put my circle at -1, and I'm looking at those two numbers. I've got -2 and 0, and I want the one that's greater than -1. Remember, negatives are like owing money, so having more money than -$1 is going to go to the right. And again, because it doesn't have that or equal to, I don't need to color in that circle. Let's go backwards. So now they've given me the graph, and it's a little bit hard to see on my screen, but it should be clearer on your paper. You can see that there's a circle right here at -2. So I know that that's the number that I'm going to be talking about. I also notice that that circle is not colored in, so I don't need that or equal to line. And I see that my arrow is going everything left. So this is smaller. So I'm going to use less than -2. For this next example, I'm going to start out with x each time. I'm going to use 4 because that's where my circle is. And you'll see that this one is going to the right. So that is the bigger numbers. I'm going to use greater than. And then because this circle is colored in, I need to add that extra line. Now over on the left, this talks about solutions. Solutions are any value that is going to make that inequality true. So if you need to find a solution, you can always graph it. You can always put it on the number line, just like what we've drawn, and then you look at where the arrow covers. If the arrow covers up where that number is, then it's a solution. So my example here says that I need to circle all that are solutions to x is less than 3. Well, if you look here, I'm actually going to highlight that. Highlighter. There we go. So solutions. Remember, I'm looking for true. All right. So I'm looking at this +5 first. I need to find +5 on this number line. And remember, I can look up at here at this example. And +5. Let me get a highlighter. +5 is right here. That is not covered up by the arrow. So I am not going to pick +5. Now if I try to find -3, I'm going to move this circle, -3 would be between that -2 and -4, and you'll see that that does cover up the circle. So I'm going to circle -3. I can look for +3. +3 is exactly where that circle is, but it's not colored in. So I can't choose +3. And 15 would be way down past my arrow, definitely not covered by that circle. So that's one way that you can look for solutions. Another way is that you can take that number and put it into the inequality sentence in place of x and see if it works. So let's try that out for the next one that they asked me for. They're asking me for negative 12 less than 3. Well, any negative number is going to be smaller than a positive number, so that one makes it true. Let's try out number 2. Is 2 less than 3? And again, I just take that number and put it in for x. Well, 2 is a smaller number than 3, so I'm going to go ahead and circle that. How about 0? Is 0 less than 3? Yep, 0 is less than 3, so I circle it. And last one is negative 8 less than 3. Again, any negative number is going to be smaller than a positive number, so I can circle that one. So whether you use that graph or you put it into the inequality statement, there are lots of different solutions. There's lots of different values that make an inequality true, and you have to try them all out. All right, now let's talking about solving. This big star here, this is the most important part of solving for inequalities. You need to solve just like our equations that we've been practicing in the past. The only thing different is that you need to flip the sign when you multiply or divide by a negative. And we'll see what that looks like in just a moment. So let's try out this first example. Again, I start out by drawing my railroads. You can circle or underline that variable to make sure that that's what you're keeping. To get that variable alone, I need to get rid of adding 2. So I'm going to do the opposite and subtract 2. That leaves x. Negative 4 minus 2 gives a negative 6. And when I look for my sign, you only flip it if you multiply or divide by a negative. Well, I didn't even multiply or divide, so I know that that sign is going to stay exactly the same. So this solution is all of the values, x is less than negative 6. Let's try out number 2. Draw your railroads. Now this one I have negative 2 and x squished together. Squishing together means multiply. So to do the opposite, I'm going to divide, show that fraction bar, by negative 2 to get x alone. Now this one is dividing by a negative, so I need to make sure that I flip my sign. That gives me a positive 3. And instead of less than or equal to, it's going to be greater than or equal to 3. So x is greater than or equal to 3. So watch out when you multiply or divide by a negative. That's the only thing that's different here. Let's go ahead and try out number 3. Here I have 2x plus negative 3 is greater than negative 33. Well, if I'm adding negative 3, the way that you get rid of adding is by subtracting negative 3. That's going to leave me 2x. I haven't multiplied or divided by a negative, so I'm going to keep it greater than. And then negative 33 minus negative 3 is negative 30. Then I've got to divide by 2 on both sides. That, even though I'm dividing, I'm not dividing by a negative, so I don't need to flip this one. I'm going to get x is greater than negative 15. Let's try out number 4. Draw those railroads. I need to get rid of that 7 first, because 7 is farther away, so it's my regular friend. I'm going to add 7. I'm going to get 10 over here, and x over negative 4 on this side. I haven't multiplied or divided by a negative yet, so I'm going to keep it the same sign. Now to get rid of dividing by negative 4, you have to multiply by negative 4 on both sides. And since I'm multiplying by a negative, that tells me that I have to flip my sign. So instead of less than, I'm going to use greater than x and negative 40. So x is greater than negative 40. 2 more examples, and then you'll have some time to try this out on your own. Go ahead and draw your railroad tracks here. First, I've got to get rid of adding 4, so I'm going to subtract 4 from both sides. I have not done any multiplying or dividing by negative, so I'm going to keep it less than. This is going to be negative 2x. 8 minus 4 gives you 4. And now I've got to divide by negative 2 on both sides. When I divided by that negative, I've got to flip my inequality. So instead of less than, I'm going to use greater than, and that's a -2. Last one here. So first thing I'm going to do is I'm going to get rid of adding -5. Now, in example number 3, if I add a negative, I can subtract the negative to get rid of it. The other way you can think about it is, how do you get rid of a -5? Well, you would add a +5. Both ways will get you the correct answer here. Haven't multiplied or divided by a negative yet, so I'm going to keep that greater than. And 8 plus 5 is 13. When I multiply by 3 to get rid of that dividing, I don't need to flip anything because that was a +3. So I'm going to get x is greater than 39. Now we had 3 examples where we saw that sign flip over. So you guys saw when we flipped numbers 2, number 4, and number 5. The only time that you flip that sign is when you multiply or divide by a negative. That's the only new step here when you solve for those inequalities. So look for when we multiply or divide by that negative number. That's a clue to you that you're going to end up flipping that sign. Make sure you have all of your examples copied down because they're going to be really good resources as we continue to practice solving inequalities.